Hello and welcome to my small tutorial on the HP 10B2 financial calculator. I just got this calculator a few days ago and I am learning to do some simple time value money problems on this calculator. So before you even get started, you want to check your settings, and there's about 100 other videos that'll show you how to set these settings. But when it comes out of the box, it's set to 2 decimal points. I've set mine to 4. And also you want to make sure that you are set to 1 payment a year. So you can check that by pressing the orange shift key and then clear all, 1 payment a year. If that comes up, then you're good to go. The main function that I'm going to discuss today are these top 5 buttons. So they are the periods, the interest rate, the present value, the payment, and the future value. If you have any 4 of these, you can find the 5th one, which is what a lot of these time value of money problems are asking for. A lot of them will ask for future value. That's the most common one that you're going to be solving for. So when you're working on a problem, you want to follow a protocol. So let's say you get a problem that looks like this. Broseph Stalin has $2,500 in an account today, which earns 4% interest. How much will he have in 10 years, say compounded annually, compounded quarterly, and compounded semi-annually? Well, your first step before you start punching anything into the calculator is to get your stuff together, or get your thoughts in order. So I like to make a little chart. You've got your 5 buttons up on top: N, I, PV, PMT, and FV. So you want to figure out which information in this problem corresponds to each of those buttons before you even punch anything in. Because if you start punching buttons willy-nilly into your calculator, you're going to lose your train of thought and it will lead to confusion and despair. So make yourself a little chart. N, I, PV, PMT, and FV. And you can just extend these out so you have plenty of space to mess around in each of these boxes, because once you get past compounding annually into compounding quarterly, you're going to have to work out what these values really are. Ta-da! Okay, so I'm going to start with annually. So now that you can see my calculator screen. So annually is going to be the most straightforward. So let's look for numbers. Broseph Stalin has $2,500 in an account today. Well, that sounds a lot like a present value, which earns 4% interest. So this is an interest rate per year. So that looks a lot like I. How much will he have in 10 years? 10 years, that sounds like a period of growth. That sounds like an N. Remember, N is the period of growth. So now we're down to 2. Future value, that's what we're solving for. How much will he have in 10 years? That's a future value. So what's payment? I don't see a payment number here. Well, payment is 0. He's adding absolutely nothing to it. So if the problem said, he has this number in an account and he's adding $100 a year or $100 a month, then you'd have a payment on your hands. But right now payment is 0 because he is lazy and unambitious in adding nothing. So payment is 0. So we're working on compounded annually. So now once you have your thoughts in order, it's time to punch in. Now you want to punch the number first and then tell the calculator what that number is. So 10, or first you want to clear the thing. Do it a couple times if you want to be superstitious. If it comes up one payment per year, then you know it cleared. So now you're ready to punch in. 10 is N. 4 is I. 2500 is PV. Payment is 0. You can go ahead and punch 0 PMT, or you could just leave it blank if it's 0. And then punch nothing in to solve for FV. So punch FV. And it'll come up as a negative number. This is because the calculator needs to balance it out. A lot of people will put the present value in as a negative number, or you can just keep track of it in your head. For these future value problems, it's not a big deal because you put in 2,500, you're taking 3,700 out. You understand, that he's not owing 3,700 because he put, he saved money. That's ridiculous. So 3,700 and then 61 cents. You want to check your rounding. The next digit's 0, so 0.61. So that's annually. That's probably the easiest. I'm going to go ahead and clear out my calculator. That's that orange shift key, C. And it comes up one payment a year, so I know it cleared. Semi-annually. So how many periods per year is semi-annually? Well, that's 2. A lot of bonds do semi-annual payments. Semi-annually. Okay. So to do semi-annually, we're going to change a couple of the numbers before or as we punch them in. So we're going to change N and I. N, we're going to do the amount of years times the periods per year. So that'll be amount of years, 10. Periods per year is 2, semi-annually. For the interest rate, because obviously he's not doing it for 20 years, he's doing it for, 10 years with 2 payments a year. So we've got to adjust this annual interest rate to not completely blow out our numbers. So we're going to do the periods over the interest rate. So, or the interest rate over the periods, sorry. So 4 over 2. So interest rate over the number of periods. So these two will kind of balance each other out and give us a number that's, more in touch with reality than if you only adjusted one. Present value hasn't changed. She's still sticking $2,500 in the account at the start. And payment has not changed. It's still 0. So let's figure this out. Now you can do this math beforehand and then stick it in the calculator. But I'm trying to get into the habit of letting the calculator do it, because sometimes this number, when you're going to be dividing by some weird things and getting some repeating decimals. So rather than, getting something like a third and then putting 1.333, you let the calculator do it and it'll kind of preserve the integrity. You'll only be off a couple dollars or a couple cents, nothing really material, but it's a good habit to get into. So let's clear our calculator, make sure we're not using last question's data, and then go 10 times 2 is N. 4 divided by 2 is I. 2500 is PV. What is FV? So I got $3,714 and 0.8685. So that's 87 cents. You want to round that up to the nearest cents because we're not dealing in fractions of a penny here. So 3,714.87. Okay. So let's do the same thing with quarterly. So quarterly is 4 periods a year. So we're going to do 10 years times 4 periods, and then 4% interest rate over 4 periods. Present value is still 2,500. Payment is still 0. Let's go ahead and punch that in. Clear my calculator first. Then go 10 times 4 is n. 4 over 4 is I. Honestly, you could do that in your head, but just get in the habit of doing it the same way every time, so that when you take the test, you don't have to think about exactly what you're doing. You can just punch it in and think about the more important things. Present value is 2,500. Payment is still 0, so I'm not even going to punch it. And then I'm going to press FV to solve. 3,722.159, so we'll call it 16 cents. So take a moment to look at your answers to make sure they make sense in the real world, because occasionally you can make a stupid mistake, and if you're just taking the numbers as they are without even thinking about whether they make realistic sense, you're prone to leaving yourself with a wrong answer. So compounding annually versus semi-annually versus quarterly, you're obviously always going to get more money the more you compound. It's going to be limited how much money that is in relation to, the other periods of compounding. So this looks right. My quarterly future value is bigger than my semi-annual, which is bigger than my annual, but not by a whole lot. So these numbers make sense in the real world. So in terms of test-taking strategy, just give yourself a moment to check them over. If you get one that's way off, let's say one of these was 5,000 something, that means you punched something in wrong and you want to go back and do that again. So let's do something a little different. Question number 2. Bro J. Simpson deposits $10 in an account that pays 5% interest compounded annually. How much will he have at the end of 10 years, 50 years, 100 years, and 1,000 years? All right, step 1 is get your thoughts in order. So you want to make yourself that little chart with N, I, PV, PMT, and FV. Now we're still solving for future value. You can tell that from the question, how much will he have at the end of 10 years? That's a future value. So we're still solving for that. Looks like we're compounding annually across the board here, so we don't have to do any of that, funny adjustment on the N and the I. But what we are changing is N. So this will be relatively straightforward compared to the last question. So, first you want to get your thoughts in order and figure out what is what. So, $10, he deposits $10 in an account. That is a present value. And he's not making any payments. I don't see anything in the question about him making any continual payments into this account. So payment is 0. Future value, that's what we're solving for. Interest rate, 5% interest compounded annually. And N is what we're changing up over here. So N would be 10 years. These are all the same. Then 50. Then 100. Still the same. And then 1,000. Very good. So, next step is clear your calculator. Looks like I've got last question's data still in my calculator, so I'm going to press orange shift key, clear. And you see it came up 1p_year, which means it cleared successfully, so I'm ready to go. N is 10. 10 is N. 5 is I. 10 is PV. No payment, so I'm going to skip it. You can enter 0 in if that's your style. Solve for FV. 16.288, so that rounds up to $16.29. 10 years. Well, I'm sure that there are faster years to make an extra $6.29 over 10 years. Let's go with 50. What is 50 years? We have 50 is N, 5 is I, 10 is PV, no payment. FV is $114.67. So that's significantly more than $10. Thank you, compounding interest. I'm going to go ahead and clear my calculator again. Now we have 100 is N, 5 is I, 10 is the present value, no payment. What is future value? $1,315 and a penny. Okay, this is pretty straightforward now. Let's try it with an N of 1,000 years. So we have 1,000 is N, 5 is I, 10 is present value, no payment. What's the future value? What is this? 1.5463E22. Well, obviously, after 1,000 years of interest on a $10 deposit, he's not getting, $1.54. What this actually is, let's see here, 1.5463. So that's 22. Move the decimal back. So I guess I need 18 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, let's add some commas. This shouldn't exist. Okay. 15, and that's a sextillion. 15.4 sextillion So if you've got a long time to wait, you can become very rich if you are sure that interest rates will, if you can get a 5% interest rate for 1,000 years. So all you immortals out there, take note of the sheer power of compound interest. This has been practice of time value of money with the HP 10B2 Plus financial calculator. And that is that. $15.4 sextillion.